we're going to be pretty soon focusing a bunch on derivatives, if you haven't noticed that. I know some of you all are being good students and looking things up, and it's trying to tell you different methods to do it. Okay, we're going to learn those pretty soon, but in the meantime, they're going to start calling the derivative lots of different things. They're already doing that. But we're going to have some notation. Instead of f prime, they might call it y prime. Same idea. Okay. This one's very common. That's a fraction bar. My word doesn't like it, but it's dy dx. It's not dy over dx. That is a symbol. It's just dy, kind of a pause, dx. Or in words, it says the derivative of y with respect to x. This is what we call Leibniz notation. One of the founders of calculus would be Wilfrid Leibniz and Isaac Newton. The Leibniz guy created this. And we'll use this a lot later, but this is close to the same. df dx. Again, it's not df over dx, okay? Or the derivative of f. F is the function, so it's basically the same thing with respect to x, okay? And then this one is nice if you are looking at a specific function here. Just to do a bland y, you would probably not use that. But if you say you wanted to find the derivative of, and we don't even know how to do this yet, of y equals cosine x, you could do this. And that way you know what you're finding the derivative of. Okay? So it's very nice. What you don't know is that there was a cookie cracker slash.
All right, well, one of my pointed out is y prime.
Y prime. Okay, that sounds good. All right. Give me another one, Claire.
Slope of tangent line to curve.
Awesome. Slope of the tangent line. Okay. F prime. Okay. I don't know if that is those separate things. All right. Give me another one, Kaylin.
dy dx.
dy dx. All right. Good. I like how you said it. Nice. Emma? df dx. Okay. All right. Let's have some words. There's some phrases clearly up here. Claire.
Instantaneous rate of change.
Ooh. Instantaneous rate of change. Very good. Because here's the thing, they're going to say, find the instantaneous rate of change, and you're going to think, oh, that is just the derivative. But if you don't know that, then you're going to be like, I don't know how to do that. All right, what else? No. Average rate of change is different. Velocity is one, yes. Velocity is, the derivative of the position function, whatever that might be. Okay? What else? Claire? Yeah. Slope of the curve. Yeah, but that's kind of.
Isn't that the same thing as just d?
Yeah, it's just a little bit. I mean, it's a different one because you have to understand what that means. So yes. Okay.
This is coming up in it. All right.
Anything else? Anything else? All right. How many you got? How many did you get, Claire? Give me a few. You only had total? Yeah. 6. Okay. Anybody have more than 6? 6. Okay. All right. Did you have? These are just. Okay. Oh, you're not. There's nothing under there. Okay. Shh. Focus, please. On calculus. All right. What about? I think we might have I'm trying to think if we missed any. Slope of the tangent, slope of the curve, instantaneous velocity, instantaneous rate of change. I think that's good. So, let's see. Here we go. Okay. Find the derivative of a function given a formula. All right. We've done most of this before. We haven't talked about this piece yet. And, of course, we're going to graph. Okay? All right. So, go ahead. Find f prime of x. Go, go, go. Find f prime of x. Here's your formula in case you don't know that right now, but you should. We're doing part 8. Emma, you want to come up here and do it now? No, do it on the board. Do it on here. Can I do it on the board? She can do it on mine. Sure. What if I get it wrong? Yeah, that's me. I won't let you make a mistake. No. Up here. I already made a mistake. So. That's my handwriting. Oh, yeah. That's just x. F of x plus h. What happens to f of x? Okay, you just made a mistake. Thank you. All right, this is making me nervous. Okay, I'll whisper.
Yeah. Like if you want to do it so well, then you just do it. That's what I say to my mom.
You can scoot it over there.
You can make that a little smaller. Just right.
Got it? Yeah. Make a little arrow.
Minus heads.
Made an arrow too. Thank you, Randy. When did this just show up? From the beginning. Do that. That's right. That's right. Let's leave it time. I think so, yes. If you'll get it. Yep.
Okay, I got it now.
What happened to X? You were right to here. Oh, it's have a minus one. Yeah, there's on the board. Or something in yourself. And plus or minus one. There's a limit. Minus. Where's the minus one? Now you right. I like to simplify. I don't believe it. H is 0. Your H. That's all. Oh my gosh. Okay. What'd you do? Okay, thank you, Emma. All right, now, where'd y'all get the plus ones? Was that at my plus H? Where'd you all get the plus ones? There was like 3 people that I saw had plus ones here instead of a minus one. So you just remove these parentheses and you distribute. mean, it's just such an elementary mistake. I'm surprised you're all still making that. Especially, who's digging their phone here? Was mine? I don't think so.
How do you ding out?
All right. Anyway, your algebra is killing you, girls. And as many times as I've reminded you about that negating the whole quantity, you all got to quit not forgetting to do that. Okay. All right. So, let's talk about in the calculator. Let's put F1, Y1 is the first one, and X2, Y2 is the second one. Okay? And then we're going to do it. Okay. X squared minus X, and 2X minus 1. Standard window should be sufficient. Yep, I believe that.
So how do you have a little dog?
I just got it. We don't want it. We don't want it. Because it's supposed to.
I don't like that.
Let's 2X minus 1. Okay. Now, the red is the function, and the black is the derivative. Okay? What would be the domain? We're doing part C now. X squared minus X. Domain. All real numbers. There's not going to be any issues with plugging in. What about C? The domain of F prime. Yes, it is. What's the same? Again, all real numbers. Okay. Here's what you need to remember about your domains. The domain of F prime is what we would call a subset of F. It can be the same or smaller. It will never be larger, because that doesn't make sense. So if it wasn't ever included in your X domain for F of X, then it wouldn't be included in F prime. Okay, so we're going to revisit this F and F prime here in a minute. I don't know how far I got today. Because I was